In this video, we will look at how force, mass, velocity, and acceleration are all related. To review force, mass, velocity, and acceleration, you can watch these videos. Remember that velocity is the speed in a particular direction, a vector quantity. To change the velocity of an object, there needs to be a force acting on it, and the object is accelerating. If the direction of motion is unchanged, acceleration describes the rate of change in speed. It can be calculated using the formula acceleration A equals final velocity v minus initial velocity u divided by time taken t. For example, if the cyclist goes from 4 meters per second to 6 meters per second in 10 seconds, then her acceleration will be 2 meters per second per 10 seconds, or 0.2 meters per second per second. Any interaction that causes an object to change its speed or direction can be described as a force. The unit of a force is the Newton, N. If an object changes speed or direction, we know that an unbalanced force must be acting on it. Newton's second law states that the acceleration of an object depends on the mass of an object and the force applied. So, for our cyclist, the heavier she and the bike are, and the quicker she wants to accelerate, the harder she has to push. This can be summarized in the equation. Her push depends on her and the bike's masses combined, and how fast she accelerates. Or, the force is equal to the mass times the acceleration. Or, F equals m times a. When force is measured in newtons, mass is measured in kilograms, and acceleration is measured in meters per second. Remember that slowing down is also a change in velocity, but this time the acceleration will be negative. Suppose she applies the brakes. Her speed changes from 6 meters per second to 2 meters per second in 4 seconds. What's her acceleration? Pause the video and think. Acceleration A equals final velocity v minus initial velocity u over time taken. So acceleration equals 2 minus 6 over 4, or minus 4 over 4, or minus 1 meter per second squared. So we can already see how force, mass, velocity and acceleration are related. Now let's see how we can use these formulae together. A motorbike of a mass of 80 kilograms increased in speed from 10 meters per second to 30 meters per second in 10 seconds. What size force acted on the bike? First, we must calculate the acceleration of the bike using the formula. Now we know the acceleration, we can calculate the force using the formula F equals ma. What are the units of the force? Force is measured in newtons, so equals 160 newtons. Now you try. A runner of a mass of 80 kilograms starts a race, reaching a speed of 4 meters per second by 4 seconds. What force is acting on the runner? Pause the video while you work it out. How did you do? Let's try one more. A jet fighter of 22,000 kilograms travelling at 65 meters per second, lands on an aircraft carrier and is brought to a stop in 3.5 seconds. What is the deceleration and force involved? The negative answer shows negative acceleration. In other words, it's slowing down. You'll need more than an elastic band to exert a force this big, so now you can see how force, mass, velocity, and acceleration are all related.